Welcome back to my channel. Now today we are starting Chatelier's principle. So according to this principle, if a system at equilibrium is subjected to change of concentration, pressure or temperature, the equilibrium shift in a direction that tends to undo the effect of the change. So it means the reaction should be have the quality of reverse or undo the effect of the following changes. So the first change is effect of change of concentration. So the effect of change of concentration in a chemical reaction increase the concentration of reactant, result in shifting the equilibria in favor of product. That means equilibria shift shifting the equilibrium in favorable of products. So increasing concentration of products result in shifting the equilibrium in favorable of reactants. So if we increase the concentration of reactants, that means the reaction will proceed in the forward direction, and if we increase the concentration of products, then the reaction will be proceed in backward direction. The second one is the effect of change of pressure. So the first one is, according to the principle, if pressure is increased, reaction will take place in that direction which brings lowering the pressure or lowering the number of moles. So there are some points on the basis of which we can explain the change of pressure. So the first one is, if we increase the pressure, then the equilibrium in that direction where the number of moles is decreased, means the delta n value should be less than 0. For example, we will react nitrogen and hydrogen to give ammonia, where the value of delta n is 2 minus 4 equals to minus 2. The second point is, if we decrease of the pressure, the shift the equilibrium in that direction where the number of moles is increased, means the delta n should be greater than 0. The example for this point is PCl5 gives PCl3 plus Cl2, means the delta n value is positive. And the final last one is, the change of pressure has no effect if delta n is 0, means there is no change in the value of moles. The example is, hydrogen will react with iodine to give Hi, where the value of delta n is 0. The third change is the change in temperature. As we know, the endothermic reaction, in this the temperature is increased, so the equilibrium shift will be in forward direction. For second, exothermic reaction means the emission or the evolution of the heat. So if we increase the temperature, the reaction will proceed in the backward direction. Now the last one is the role of catalyst. The role of catalyst is that if there is a positive catalyst, the rate of both forward and backward reactions are equally, so the equilibrium will attain in less time, means the equilibrium state will be attained in less time duration. And if we have negative catalyst, then the increase in temperature will be if we increase the temperature, the equilibrium shift in forward and backward direction will be attained in more time the equilibrium. So these are vice versa to each other, and after that we will start the application of Le-Chatelier principle on physical equilibria. So the first application for the Le-Chatelier principle is the formation of Hi, means we will use hydrogen and iodine which react together to give Hi, means the delta H value is minus 12.4 kilocalorie. The favorable conditions for forward reactions are high concentration of H2 or I2, means the concentration of H2 or I2 should be high. The second is unaffected by the pressure, means the delta n g is equals to 0, means there will be no effect of pressure, no effect of pressure. So the third one is no effect of addition of inert gases, means there is no effect if we add inert gas. The second example is the Haber's process of synthesis of ammonia. So we will use nitrogen plus 3 hydrogen, which gives 2 moles of ammonia. That means the delta H value is minus 22.4 kilocalorie. So the favorable condition for this reaction is high concentration of nitrogen and H2, means nitrogen or H2 should have high concentration. The second one is high pressure, means there is high pressure. The third is low temperature, as the reaction is exothermic. Although the low temperature favors the formation of ammonia, yet an optimum temperature is set. As the rate of reaction is very slow at the low temperature, the temperature of 500 degrees Celsius is selected and pressure of 200 atm is applied. The third application is manufacture of sulfuric acid by contact process. The first step of the process is the conversion of SO2 into SO3. So the SO2 will react with oxygen to give 2 moles of SO3. So the favorable conditions for this process is increase in temperature, as delta Ng is equals to -1, high concentration of SO2 and O2, the low concentration of SO3, and the last one is the low temperature, as the reaction is exothermic. So these are some applications of Le-Chatelier principle. I hope you like the video. Please do not forget to like the video and do subscribe my channel. Thank you so much.